Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the area under a curve. So we're going to look at finding the area under the curve y equals x squared. So if I include all this area here and all this area over here under the curve, of course it would be infinite because this curve goes on forever. So we need to limit the domain. We need to find the area under a curve between two given x values. So we're going to look at finding the area under the curve y equals x squared between x equals 1 and x equals 5. And we'll use three different approximations. So what I actually want to find is this area here under x squared between x equals 1 and x equals 5. This is not an easy area to find because this shape is not a shape I'm used to working with. Now, apologies for the drawing. It might look like the yellow bit is a triangle, but it's not because this is not a straight line. So we can't just use the formula for shapes that we know. So one way we can approximate or estimate this area under the curve is by drawing lots of rectangles. So we're going to look at an example where we use 2 right, 4 left, and 4 centered rectangles. So let's start here with 2 right rectangles. Okay, we can clearly see there's 2 rectangles. So why are they right rectangles? Well, it's because they hit the curve on the right. So you can see for this rectangle here, where it hits the curve is to the right of the rectangle. Similarly, for this one here, it hits the curve on the right of the rectangle. So all I need to do to estimate the area in yellow, I'm just going to find the area of this rectangle and add it to the area of this rectangle. So of course, you know, the area of a rectangle formula hasn't changed since primary school, length times width. So width times length. What we're going to do is make the width of each rectangle the same. So the width, of course, in this first example would be 2. So 2 and 2 because this whole distance is 4. So how would I find the length of the rectangle, this thing here? Well, all I need to do is find the value of the function at this point here and the value at this point here. So, of course, this would be the value 3, halfway between 1 and 5. So this distance here would be 3 squared. The y value here would be 9. So this first rectangle has an area of 2 times 9. And for this rectangle here, well, its width again is 2, and its length is going to this time be 5 squared. So it will be width 2, length 5 squared, which is 25. So the total answer we get there is 59, and we just call it units squared. All right, so let's look at this example here. So now we have 4 rectangles. We're still trying to calculate the same area under the curve, all this bit here. So we're using more rectangles, this time 4, but they're left rectangles because you can see here the rectangle hits the curve on the left. It is the left corner of the rectangle that touches the blue curve. So let's go now and find the area of each of these rectangles. This time, because remember I said the width is the same, each width will be 1, and we can find their lengths exactly the same way we did over here. So, of course, this would be 2, 3, and 4. So this first rectangle here has a width of 1, and it meets the curve here when x equals 1. So the length is 1 squared, which is 1. The area of that first rectangle is 1 times 1, which is obviously just 1. So then let's look at this rectangle here. Well, it's got another width of 1, but this time the length is going to be 2 squared, which is 4. That's this point here. The y value here, which is this distance, the y value is 2 squared, which is 4. And of course, in the third rectangle, width is 1, length is 3 squared, which is 9. This distance here is 9, and then the final rectangle will have width 1 and length 4 squared, which is 16. So that gives us 30 units squared. So let's now do the same 4 rectangles, but this time they're meeting the curve in the center. Sorry if that's not clear from my drawing. So again, we would have these points 2, 3, and 4. So each rectangle again has width 1, but the length will be slightly different. So if this rectangle meets the curve in the center, of course, the middle of 1 and 2 is 1.5. So the width is 1, the length is 1.5 squared, which is 2.25. And for the next one, width is 1, but if it meets the curve in the center, it will hit when x is 2.5, so the length will be 2.5 squared, which is 6.25. And then similarly, the next one, it will have width of 1, it meets the curve halfway between 3 and 4, so x is 3.5. So if x is 3.5, y would be 3.5 squared, which is 12.25. And for the last one, length is going to be 4.5 squared, halfway between 4 and 5. So 20.25. And so that gives us an answer of 41 units squared. So it turns out the actual area in yellow, the area under the curve y equals x squared between x equals 1, x equals 5, turns out that actual area is 41.3 recurring. Don't worry how I got this. You'll see that in subsequent lessons. But let's just see what's going on. When you do rectangles on the right, you can see this wasn't very good estimate because it overestimates. Each of these rectangles is larger than the section that's actually shaded in. You can see there's a bit more that I've overcounted in each rectangle. So when you do right rectangles, it's overcount. When we did left rectangles, it was an undercount because we missed this little area here and this little area here and that. Each of these rectangles was smaller than the region covered in yellow. You can also see this is closer to the answer than that one. So we're more accurate the more rectangles we have, and you can see clearly we're more accurate when the rectangles were centered. So if I want to get as close as possible to this, I'd want to have more and more rectangles, and centered rectangles tend to give us a better approximation. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.